Okay, so today we're going to look at polynomials, and in particular we're going to find the value of a given polynomial. We have two examples. The first one is x squared plus 4x minus 3, and we want to find f to the 3, which is we want to replace x with 3. Secondly, the next polynomial is x to the 5 plus 3x to the 4 minus 2x squared plus 3, and we want to find f to the minus 2. That is, replace x with minus 2. So the method I'm about to show you, you may have seen before, you may not, but I believe it's a straightforward way in order to do this, in particular for more complicated polynomials. So the first thing we do is we draw out an L shape, like so, and the number that we're replacing with x, 3, goes to the top left-hand corner. We're then going to get the coefficients of the polynomial and write them along the top here. So the coefficient of x squared is simply 1, it's just x squared. The coefficient of 4x is 4. And lastly, we have minus 3. So we drop the first number down, like so. So the 1 goes to here, and then we multiply the number which is replacing x. 1 times 3 is 3. Then we add the 4 plus 3 to give 7. We then, again as before, multiply. 7 times 3 is 21, minus 3 gives us 18. So there we have it. F to the 3 for this polynomial is 18. And just to check, a more conventional method would be x squared plus 4x minus 3. We replace the x with 3, 3 squared plus 4 times 3 minus 3, which gives 9 plus 12 minus 3, which again gives us 18. So both of these methods are correct and they generate 18 as the result. Now the reason I like this particular method is because for some more complex polynomials, such as the second example, it involves a lot of computation to get the answer. However, using this method, we draw out the L shape big enough so that we can incorporate all the coefficients. Again, the minus 2 goes to the top left hand corner. The coefficient of x to the 5 is simply 1. The coefficient of x to the 4 is 3. Now notice what we're doing in order. It's x to the 5, x to the 4. Now there isn't an x to the 3, but that doesn't mean we can leave it out. We have to denote x to the 3 with 0, because there is no x to the 3 term. And secondly, we work our way down, minus 2, and we notice again there is no x term, so again we have to denote it with 0. And lastly, we have 3. So what we've done is these numbers reflect the coefficients of the polynomial. X to the 3 and the x are simply 0 because they're not there. So again, we drop down the 1. As before, 1 times minus 2 is minus 2. We add down the way, 3 plus minus 2 gives us 1. Multiply gives us minus 2. 0 plus minus 2 is minus 2. Minus 2 times minus 2 cancels to give positive 4. 4 is 2, simply 2. 2 times minus 2 gives us minus 4. 0 plus minus 4, minus 4. And then again, the cancellation of the minuses gives a positive 8. So 8 plus 3 is 11. So notice the multiplication and the addition has been single digits and it's been fairly straightforward. Now what we would have had to have done if we're using a more conventional method for this would have been like so. We would have had x to the 5 plus 3x to the 4 minus 2x squared plus 3, and f is minus 2, which again is x equals minus 2. So we would have to replace minus 2 where all the x terms are. So for this particular one, we would have minus 2 to the power of 5 plus 3 times minus 2 to the power of 4 minus 2 times minus 2 squared plus 3. So minus 2 to the 5, the easiest way to think of that is minus 2 times minus 2 times minus 2 times minus 2 times minus 2. 1, 2, 3, 4, 5, just a quick check. So it's 5 times itself, minus 2 to the 5, and that would give us minus 32. So minus 2 times 2 times minus 2 times minus 2 times minus 2. We always have to be careful of the plus sign because it could be plus or negative. In this case, it's minus 32. So that gives us the first term. Next, we would have to do 3 times minus 2 to the 4. So again, that's 3 times minus 2 times minus 2 times minus 2 times minus 2. So we would then have 3 times, and this would be positive 16, which would give us 48. So minus 32 and 48, and that's the first two parts of the polynomial. Then we would have to move on to minus 2 times minus 2 squared, which would be minus 2 times 4, which would give us minus 8. And lastly, we have 3. So we would have to add minus 32 plus positive 48 minus 8, and then lastly 3. So minus 32 minus 8 would give us minus 40, and then 48 and 3 would be plus 51, so the difference is 11. So we got the answer, which is correct, which is 11. But as you can see, this method, there's an awful lot of computations involved, and it is very, very easy to slip up with the minuses and make a mistake. Whereas this method, simply draw out your L shape, plug it in, and as you can see, it's fairly straightforward. I hope you've enjoyed this video. Thank you.